let's do a question. So it says that using the following to answer questions 8 to 11, indicate the letter corresponding to the type of graph that would be best for the following situations. Each answer choice may be used once, more than once, or not at all. So 8 says that we want to plot the distribution of the amount of soda consumed per week by 100 adults who volunteered to participate in a certain study. So which graph can we use to represent this? Yeah, so we use a histogram because remember that when we're dealing with large amount of distribution, we normally use a histogram. Also, a second question using that, so what type of sampling distribution, sampling design is it? So what kind of sampling design would it require? Voluntary, because as it says, adults who volunteer to participate in a certain study. All right. We asked students the reason they were late to class. Students may give more than one response. Pi, no, it wouldn't be pi. Because remember, you know, we can only use pi when we have one answer. You can only use a pie chart when you have one answer. We use a bar graph, so it will be C. So remember, a bar graph is used when you can give more than one answer. And there's no numerical value to it. So it can be late for more than one reason. Your other class was too far. You were in the bathroom. You had an emergency. You were at the health clinic or something like that. 10, a lecturer wants to compare the scores on an exam based on faculty the student is in. What would we use for this? So a lecturer wants to compare the scores on an exam based on the faculty the student is in. So the best thing that we could use is a side-by-side box plot. And you guys know that a side-by-side box plot is a graphical box plot is just a graphical representation of the 5-number summary where we have the minimum, the maximum, and then we have our interquartile ranges from Q1, Q2, which is our median, and Q3, which is our interquartile maximum value. So what they're doing is comparing to see if persons in SOCI have a higher grade than persons in faculty of law or faculty of technology or med. So yeah, the side-by-side box plot would be the best representation of comparing the scores on an exam. So you could compare the maximum values, the maximum scores for persons in a different faculty, the minimum scores for persons in a different faculties, and the median values. This is how your exam is going to be, guys. You guys have to reason out why you choose this, why this is the best thing to choose, and so forth. A researcher wants to display the per capita GDP for the 15 full members of CARICOM. What's the best thing to use? Yeah, so the best thing to use would be a stem plot. Remember I told you, we normally use a stem plot when we have a sample of 20 or more or 20 or less, observation of 20 or less. It's a graphical representation, and if you want to graphically represent first GDP, the best thing to use would be the stem plot. All right. So describing data. So describing data, we normally use sums, which is the shape. So the shape is what's the overall shape of distribution. So is it symmetric or skewed, and how many peaks does it have? Then we have the unusual or normally. Are there any unusual points? You know that outliers, we can either have our errors, outliers, or influential point. An outlier is normally an influential point. We know that an outlier is a cause of a distribution being skewed. So once you have an outlier, you know that your data is going to be skewed. M stands for middle, with where is the center of the distribution. So we normally, the middle, we have the mean, the median, the mode. We know that the mean has to do with the overall average. The median has to be with the middle value, the value that lies in the center. And then the mode is which value occurs more frequently. Then S is the spread. How much variation is there? So we have the range, the standard deviation, the variance, and interquartile range. So the shape. First thing we deal with the S. So there are two ways to describe the shape. So we have one, the number of peaks, and two, the skewness. So the number of peaks. It's unimodal if it has one peak, which is what we normally work with. Bimodal, I know that bi always means two. So bimodal means it has two peaks. And then if it's multimodal, it has 3 or more peaks. But we normally use data with unimodal, which means that it has one peak. So the skewness. So skewness means it's a measure of symmetry or lack thereof. So a distribution is symmetric if it has approximately the same shape on the left as it does to the right of the center point. So we know that the distribution is symmetric when the mean is equal to the median. It means that we don't have any outliers, so there are no outliers. So it's symmetric when the mean is equal to the median and there are no outliers. A distribution is skewed if one of its tails is longer than the other. So we have two types of we have two types of skewed distribution. It can either be negatively skewed or positively skewed. So it is skewed, so negatively skewed, it means that it is skewed to the left, and this means that the mean is less than the median. So the longer tail is to the left. Again, we have two types. It can be either negatively skewed or positively skewed. If it is negatively skewed, it means that it is skewed to the left. That is, the mean is less than the median. Therefore, the longer tail is to the left. Then if it is positively skewed, it means that it is skewed to the right. The mean is greater than the median, and the longer tail is to the right. In both cases, we have outliers. So if it's negatively skewed, we have a negative outlier. And if it is positively skewed, we have a positive outlier. As I was saying, so skewed data are caused by outliers. These are points which are either much larger or smaller than other points in the data set. Once the data is arranged in numerical order, outliers can only occur at the beginning and or at the end of the data set. So this was what I was talking about when we have a symmetric distribution. When we have a symmetric distribution, it means that everything is equal. So the mean is equal to the median and the mode, and it's in the center. So this is when we have a symmetric distribution. There are no longer tails. Everything is normally distributed. So these are examples of, this is how it looks like, how you know it's supposed to look. If it is, okay. If it is bimodal, it has 2 peaks. And if it is multimodal, it has 3 or more. So in this case, it has 3 peaks. So we looked at the shape, the unusual. Now we're going to be looking at the M, which is the center or the middle. So we have the mean. Person whose mic is on, can you please turn it on? So we have the mean. So the mean, which is the average or the arithmetic mean, it is simply the sum of all the numbers divided by the number of numbers.
Oh,
so the mean is the average. So if I wanted to know the average grade for everybody that did Econ 1005 mid-semester 2, I will just add everybody's grade. Even if I didn't do the mid-semester, I will add everybody's grade and divide it by the number of persons that is doing introduction to statistics. Once you're registered for those. So that's how I'll find the mean or the average. Now the mode, as I said before, it's the element or value that appears most frequently in the data set. So it's the simplest measure of the center. If no element of the data set appears more often than any other value, the data set has no mode. So if everything appears one time and stuff like that, we have no mode. Next, we have the median. So the median is the middle value of a distribution. It divides the data into